This is an introduction to graphing some nonlinear functions. So nonlinear just means the graph won't be a line. So in each of these cases, we should expect to see something other than a line for our graph. Remember that the equation for a line would be one of a few forms. So it could be y equals mx plus b, could be ax plus by equals c, but all that's involved would be multiples of x, multiples of y, and then constants. So when we see something like x squared, that square tells us it won't be a line. Right? And probably from some class in your past, you might remember that if you see an x squared involved, that what you'll see should be a parabola. What we need to do in this section is become very familiar with the basic graphs of a parabola, x squared, an absolute value, and a square root graph, so that we can, in the next section, start moving them around left, right, up and down, things like that. So for now, we'll go ahead and make tables of values. Let's do -2, -1, 0, 1, and 2 for our x's, and then determine the y's that go with them. So if f of x is x squared, for the y we'll have -2 squared. Remember to square the negative also, so we'll get 4. This would be -1 squared, so we'll have 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So we've got these points we can plot. -2, +4, -1, +1, 0, 0, 1, 1, and 2, 4. And we see the familiar shape of a parabola here. If we were to use 3, we'd have 9, which is off this chart. But we can go ahead and connect those points. But the points that we graphed with x equals 0, 1, -1, 2, and -2 are the key points we want to include on any parabola graph. Just for good measure, let's talk about the domain and range. The domain for that graph, notice that it would keep going left and keep going right, so -infinity to infinity. And the range, it doesn't go below 0 for the y values, but it does hit 0, so we would do 0 to infinity with 0 included. So that's one of the graphs with which we should be familiar once this section is done. Parabola graph, x squared. Another graph that we want to know well so we can move it in the next section would be this absolute value of x graph. Let's use the same x values, -2, -1, 0, 1, and 2. Throw them into the absolute value function. Here we'd have absolute value of -2, which is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. For positive values, we just get the same thing back. Right? And if we plot those points, we've got -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. This graph will look like a V. On the left to the left of 0, it should have slope -1, and to the right, it should have slope 1. Might as well do the domain for this one and the range also. Domain would be everything, because it keeps going left and right, and the range would be the same as it was in the last example, 0 to infinity. So the absolute value graph will look like a V with slope -1 on one side, +1 on the other side, and the corner or the vertex at 0, 0. Now the square root of x graph. I don't want to pick the same x values I did for the others because those x values aren't all going to give me nice y values. For example, I can't put -1 in for an x because I can't do the square root of -1. But if I put 0 in, I have square root of 0 is 0. If I put 1 in, the square root of 1 is 1. And then putting 2 in isn't going to do me a lot of good because square root of 2, I don't know without a calculator. But if I use 4, I'll have square root of 4, which is 2, and then the next nicest x would be 9. which would give me 3. And if I graph 0, 0, 1, 1, 4, 2, and 9, 3. And I don't have negative x values, so it's going to look like that. I'll keep going to the right, but not to the left. And then let's list the domain and range. The domain on this one would be everything to the right of 0, so 0 to infinity, and the range would be everything above 0, including 0. So there are those 3 basic graphs that we really need to know. The graph of y equals x squared, y equals absolute value of x, and y equals square root of x. Okay. Then just some general function questions again. For this function, if we want to know the domain, we want to look to know how far left and right does this go. And it looks like it goes as far left as -7 and as far right as 6, and it's all the values in between. So we would list it as an interval from -7 to 6. And then the range I'll do in blue. And we're looking up and down, so it looks like this graph goes as low as -6. Let's see, 1, 2, 3, 4, 5, 6, -6, and as high as 3. So -6 for the low y value and 3 for the high, and I'm including brackets because we actually hit those values. F of -1 is the y value when x is -1. So I would go to where x is -1 and find the point on the graph. It looks like y at that point is -6. So I would write f of -1 is -6. And then if I'm looking for the x's such that f of x is -3, remember this is the same as y is -3, which would be a horizontal line. So we can draw in that horizontal line and figure out the x's at which the y value is on that line. It looks like x equals 2 would be one of the values, and -5 for the other. So x equals -5 and x equals 2 would be the x's for which f of x is -3, right? Because f of 2 is -3 and f of -5 is also -3. And the last examples here are just determining from the equation whether the graph is linear, whether the function is linear, and then sketching the graphs. So hopefully you can say, look, because of these absolute values, this is not linear. But the other one is in the mx plus b form, so that will certainly be linear. Let's graph the linear one first. Remember, we want to start with the y-intercept, which is 0, 3. So we start at that point, and then we use the slope to move from the y-intercept. In this case, the slope is 1/2, which means up 1 and right 2 from the y-intercept to get to another point. So we'll go up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2, and so on. And then we can connect those points. So that should look linear, and it does. Y-intercept 3 and slope 1/2. And the other one, because of the absolute values, we know we should be expecting this kind of shape. And in the next section, we'll talk about how to know exactly where the absolute value has shifted to in this case, but for now we can just pick some x values and find the y's that go with them. Notice if you pick x equals 3, that y would be 0. So if we pick 3, we're going to have absolute value of 3 minus 3, which is just 0. If we pick 4, we'd get absolute value of 4 minus 3, which is 1. If we pick a value on the other side of 3, like 2, we will also get 1. And if we pick 1, we'd get 2. Let's plot those points, and then we'll be able to see what this graph looks like. So we knew we were expecting a V, and because we can see this corner right here, we know that that's, so this place where it turns around, that's where the corner is going to be, which allows us to sketch the rest of the graph. So determining where the y value is going to be 0, or where the inside of that absolute value was going to be 0, was kind of key to getting all the points we needed. Right? So in the next section, we'll talk more about this shifting left and right, and how to predict just by looking at the formula that this is going to be the absolute value graph shifted 3 units to the right.